Alright, let's take a look at some classic examples for periodic motion, how we model them. The one that everybody likes to show is a Ferris wheel. Because it's circular, you can board it at any location depending on where you choose to put a platform, and it can move counterclockwise or clockwise, so it has all the important stuff that we need to know. Alright, let's start with it. A large Ferris wheel is 80 feet in diameter. It has 12 cars and rotates one full rotation counterclockwise every 1 minute. The wheel is boarded at car 1. This would be this car right here on the right, from a platform that is 50 feet high. Determine the equation of the function as well as the graph. Okay, so let's just go through what we know real quick. We have the standard form here that we've worked with before and all the parameters that define it, and I have redefined all the parameters over here just so you're still familiar with what they are. Let's just go down the list. The Ferris wheel is 80 feet in diameter. The amplitude is half of the total top to bottom change that you have. So in this case, it would be 80 divided by 2. So A equals 40. Alright, let's work on B. B, if we're doing this in minutes, which we are, we can see that the car rotates one full rotation counterclockwise every 1 minute. Now B is 2 pi over the period. The period will be 1, so B is just 2 pi. We'll get C, the phase shift. If you remember, the unit circle starts here on the right side and goes counterclockwise as we count around it. So this is actually the 0 point, meaning that we don't need a phase shift. So we'll just put 0 here. And D is the vertical shift that we need. If we're defining the height for this, we have to get to the center is essentially what we're determining. And we know that the distance from here to here it says that the platform goes 50 meters off the ground. So this is 40, but the distance from here all the way to the ground is 50. So D would be 50, so we can shift it upward where we start. Now let's fill that in. You get Y equals 40 sine 2 pi x plus 50. Now, instead we should graph that. I'll rewrite the equation over here. Y equals 40 sine 2 pi x plus 50. So things we know about this. We start at 50. So we'll put a line there. The highest point that we'll reach, since it has a diameter of 40 and we start at 50, will be 90. And the lowest point that we'll reach will be 10. We start at 50. It goes up since it's counterclockwise and then comes down. So let's draw that. This is not going to be a perfect drawing, but it should be representative. And there's a couple cycles of it. It would look like that. Now the cycle completes here. 1 cycle. We have 2 cycles. And if we look back, we remember the period was 1 minute. So this should be when the first cycle completes at 1 and the second cycle completes at 2. Now this is a pretty simple graph. It's just a sine wave shifted up 50 with an amplitude of 40. Let's look at a harder example. Okay, this one's going to be a bit trickier. A large Ferris wheel is 30 feet in diameter. It has 12 cars, and it rotates one full rotation counterclockwise every 3 minutes. The wheel is boarded at car 4. That would be the car on the bottom here, right here, from a platform that is 5 feet high. Determine the equation and the function as well as the graph. All right, let's go down the parameters again. We've got A. What would A be? Well, we know that the diameter is 30, and half of that would be 15. B is 2 pi over the period. The period here is 3 minutes. So we have 2 over 3 pi. C is the phase shift. Now we want to start at 0. So the sine wave normally starts here, but we want to move it back here. So we're going to make this, how far is this shift on a unit circle? It's pi over 2. Because if the whole circle is 2 pi, it would take 4 pi over 2's to make it all the way around. So this shift backward is pi over 2. And D is the shift upward, which would end up being the amplitude for the center. We're looking for the center here. Um, 15, which is half the diameter, plus the landing platform that we use to get up to the first car, which is 5 meters or 5 feet high, so 20, which gives us the equation y equals 15 sine 2 over 3 pi x minus pi over 2 plus 20. Now let's graph that as well. I'll rewrite the equation so we have something to reference. 15 sine 2 over 3 pi x minus pi over 2. That's a really bad pi. There we go. Plus 20. So this essentially tells us where we start. If we look at this, we remember that when we loaded the bottom car, we were loading at the lowest point that we'll be at. What is the lowest point? Well, it's the height of the landing platform in this case, which is 5. The center of the Ferris wheel is at 20 since it has a diameter of 15, and the highest point will be 35. We loaded the bottom and it moves counterclockwise, so it'll be moving upward right when we start. So we'll start here, it goes up, okay, it goes up and down and up and back down. Yikes. Do that again. Goes up and back down and up and back down to 5. So the cycle completes itself for one full cycle here and another one over here. And if we remember, the period in this case was 3 minutes. So we'll label the x-axis as 3 and 6 for each of the 2 cycles. I hope this helped explain it a little better. There are other examples you can use, but normally it's given as a pendulum or a Ferris wheel in this case. or just a wheel, and anything that has a repeating interval type of motion can be given for this. Alright, I'll see you guys for the next video.